Hi, today I want to share something that I've been working on recently, and that is refining our planner, as we call it. The planner is a component in our pipeline which examines the code base that we want to migrate and define an order in which we are going to migrate the files. So the first question we may ask is why we need that. So we could hypothetically just want to migrate everything at once. We click a button, we get everything migrated, and we are good to go. Unfortunately, it doesn't work that way, and maybe it shouldn't work that way. And let me explain why. First of all, typically we build a custom transpiler. So that means that we need to put some work on that. So if we were waiting to translate everything, we will need to wait sometimes to create the entire transpiler or adapt it if we're starting from a base transpiler. And so that will be a long wait, while I strongly believe in providing incremental results. So we want to be able to figure out something that we can translate rather quickly and deliver to the client. But even if we could translate everything at once, it makes sense to provide code in batches to the client, because in this way they can have some time to review it and refining it. And we don't want just to translate random files, because we want to give them a coherent group of files that they can compile and use together. And so we cannot, translate 3 random files. We need to translate the right 3 files if we want to ship 3 files. So that is the goal of the migration plan. What the migration plan is this: it consider dependencies and complexity to define an optimal order in which we want to translate the files. Now, consider this case. We have to migrate a large application which is composed of multiple modules. Call it modules, we could call them projects, we could call them libraries, whatever, but say different modules. Modules have dependency among each other. So if modules A depends on module B, then we need to translate first module B, which hypothetically have no dependencies, and only later module A, when B is already available. So we need to consider these module dependencies, and then within a module that sometimes can be very, very large, it could contain, maybe a module could contain hundreds of thousands of files, we want to do the same thing but at the file level. So we want to identify dependencies between files. The difference is that the dependencies between modules or projects are typically easily obtainable by looking at the metadata of maybe our build configuration files or our Eclipse project files or whatever. While dependencies between files needs for you to implement symbol resolution, so that I can look at the code and see that it's reading values from this other file. And so I understand that this file depends on that other file. And so that I need to translate first that other file and then this file. So that already requires some tools, typically a symbol resolver. And so using this information, you can decide the order in which to translate the modules or the project and then the single files. Now, in defining this order, we need to consider a few things. First of all, both at the project level and the file level, you may find situations where there are group of elements that are interdependent. So maybe I have a class A that depends on class B and class B that depends on class A. So I will never be able to find an order in which I can translate them, having all the the dependency is satisfied. So I need to recognize this block, and sometimes this block can be composed not of two elements, but maybe 50. And this is what we define a cluster. And so it must be translated all at once. So we may have projects that are interdependent and files that are interdependent. But then, in addition to dependency, we also consider the complexity of the element, and in particular, the incremental complexity. What I mean by that? At the beginning, we start from 0. So let's say that our transpiler doesn't know how to translate anything. Then, among the different files that have no dependencies on other files, we will prefer to choose the one that have the minimum amount of elements, minimum amount of constructs. Let's say that we find a file that have maybe just defining, I don't know, let's suppose we were translating Java, just define an empty class declaration. So there will be the concept of class declaration, maybe an import. So we look at the different kind of elements and determine how many of these elements are new with respect to the one that we have already translated. And we consider this the incremental complexity. So we pick the files that have, for which we have already translated all the dependencies. Then we pick the simplest one and we translate that file. Now, when I look at the next file, I could use a file that depends on the one that I have already translated, and I will consider the incremental complexity considering that I know already how to handle some constructs. So only the one that I have not yet handled will contribute to determine the complexity of this additional translation. And so, considering this principle, we determine a complete order in which we want to migrate the files. So we can translate elements that blocks of files that make sense per se, that can be compiled per se, can be run. And so as we work on the transpiler, we can provide initial results that the client can try to compile, run, and provide feedback as we continue the work. So maybe having a good migration plan, I think, is an overlooked part of doing a translation. And I hope made sense. And as always, if you have comments, curiosity, or feedback, including telling me how terrible I am, please feel free to let me know here in a comment or sending me a message. Thank you. Bye.